Professor Pelton. This is Algebra 2, Chapter 6, Section 5. This is properties of logarithms. There's the product rule, quotient rule, and power rule. There are many product, quotient, and power rules, but these are specifically the product rule of logs, the quotient rule of logs, and the power rule of logs is the full and proper name. So essentially, if you have a product of two things, they can be broken apart in logs or brought together if they have the same log base. So the key here is you cannot put them together if they don't have the same base. So they must have the same base for them to be put together with addition and subtraction. If it's addition or subtraction, they become multiplication or division, and then your exponents can come down for the power rule. So we're going to do this numerically first to prove it, and then use it algebraically later on to solve equations. So we're going to prove this with a calculator and kind of demonstrate the work here. So what we're saying is that log of 3 equals this number, and log of 7 equals this number. So if I was going to break this up knowing that fact, a division is actually subtraction using the quotient rule. So this is log base 2 of 3 minus log base 2 of 7, which is 1.585 minus 2.807, which is approximately negative 1.222. Okay, so let's prove that. So again, we're not doing it, we're not solving anything, we're just proving the fact that this actually works. So we can use it algebraically later on. So we use a calculator simply. So we have log base 2, and we have the fraction of 3/7. We get that value there, which is the answer that we had. We got to abbreviate. I'm sorry, round, actually. So you have, wrong key there. So we had a log base 2 of 3 minus log base 2 of 7. We said that was the same thing. Is it? It in fact is. So we've proved that the quotient rule actually works. And you can do that with any of these. So the product rule, well, 21 is not one of our options. We only have 3 and 7. But this is log base 2 of 3 times 7, which is log base 2 of 3 plus log base 2 of 7. So now we can use the 1.585 and the 2.807 and get approximately 4.392. So what's important with the product rule of logs is that you can break them apart if it's multiplication, keeping the same base. 49 is not an option in our list here, but we have log base 2 of 7 squared is the same thing, or 2 times log base 2 of 7. If we use the power rule of logs to bring down the 2, right? We brought down the 2. So this is really approximately 2 times the log base 7, which is 2.807 approximately. So it gives us a final answer of approximately 5.614. So using the stated values and without a calculator, okay, do the following 4 problems below. Okay, so they gave us log of 5 and log of 8. So log of 5 and log of 8, this would be log base 6 of 5 minus log base 6 of 8 using the quotient rule of logs. So that's approximately 0.898 minus 1.161, which is approximately negative 0.263 as our final answer. Next one, 40 is not on the list, but 40 is 5 times 8, which is log base 6 of 5 plus log base 6 of 8 using the product rule of logs. So, whoops, sorry, that's wrong. Using our approximations at 0.898 plus 1.161 for a final answer of 2.059 approximately. Okay. Next one, 64 and 125. Neither of those are on our list, but this is log base 6 of 8 squared. This one is log base 6 of 5 cubed. So using the power rule of logs, this is 2 times the log base 6 of 8. And this is 3 times the log base 6 of 5, which is approximately 2 times and 3 times those values that were given, which is 1.161. And the other one is 0.898 for final answers once multiplied of 2.322 approximately, and approximately 2.694. Okay, that is the end of part 1.